here I say that I want to reverse a linked list. So what do I mean by reversing a linked list? Let's say I have 1, 2, 3, 4. Okay, you tell me what do you mean by it. I have this 1, 2, 3, 4 and I simply want to reverse this linked list. Just think of all the different ways that comes to your mind. So let me tell you one thing. What I can do is I can traverse this, and while traversal I am maintaining a stack in which I am inserting the data part. So the data part over here is 1. I inserted 1 here, I inserted 2 here, then 3, then 4. Now let's look at it in a more careful way. So I'm going to redraw it. So basically I had a 1 here which was pointing to this 2. I had a 2 here pointing to 3. 3 was pointing to 4. And this was null. And this memory location was M1, this was M2, this was M3, this was M4. Okay. So what I did, I simply traversed and I just populated the stack in this way. Now I can retraverse, and while traversing I am popping everything from here and overriding this value to 4. This will be overridden to 3. This will be overridden to 2. And this will be overridden to 1. So this 4, 3, 2, 1 looks reverse of 1, 2, 3, 4. So what is the extra space over here? Because I needed an extra stack. So the extra space is order n. And what is the time? Time is order n. Tell me one thing. Is this the right or wrong approach? If your interviewer asks you to reverse a linked list, will he expect you to do something like this? So he will never expect you to do something like this. And why he'll never expect you to do something like this? Can you answer that question to me? Because his expectation is different. His expectation is he does not want you to play with data. And now this is a very important point. You should never play with data. You should play with links. So instead of changing the data, you have to change the links such that the linked list becomes reversed. Okay. So the expectation is something like this, that this M4 still has 4, and it is now, instead of pointing to null, this is pointing to M3, which still has 3 in it. And this M3, instead of pointing to M4, it is pointing to M2, which contains 2. Still it contains 2. And similarly this. This is the expectation. Okay, and of course this should point to null. So here it will have null. Do you understand the difference between this and this? There is huge difference between these two, because in first case the links are the same, you have overridden data. In second case, data is the same, you have overridden the links. So I told you, you have to play with the links, which is the case over here. You do not have to play with data, which is the case over here. Now tell me one thing. Why will he not want you to, why will your interviewer stop you from doing this? Because what can happen is, here the data that you have is a normal integer. So you know, copying integer and then overriding that value will be order 1 operation. But imagine if every linked list had a data which was a string and it was a huge string. In that case, creating a copy of it and then overriding it would have been very, very costly. And guys, this is a very, very real life problem. Let me tell you that. Because data can always be huge. So you should not play around with data. But links will never be huge. Link is just a pointer. So link will never be huge. So you can always play around with links in order 1 time. Right? So certain times what happens is, you might have seen certain websites. Let's say there is website 1. Website 2, website 3. So website 1, if you click a link over there, you are redirected to this. If you click a link here, you are redirected to this. And let's say there is no redirection after this. So websites can also be modeled as nodes of a linked list, nodes of a single linked list. Now let's say someone asks a software engineer that, hey, just reverse this redirection. Will you want to have the contents of this put over here and the contents of this put over here? Will you want to do that? Because if you want to do that, that is a lot of work. So instead of doing that, you can simply just revert the links. So this kind of solution is never expected. Okay, so basically reversal of a linked list or any such question that you will see, you do not have to tamper with the data, you just have to tamper with the links. Please write it. From now on you should never tamper with the data. So this was one reason, and there is second reason also. The second reason is, let's say you have created your linked list and there is a program, and let's say that program has assumed that this linked list is static. It can be the case, but that program is assuming that this is a read-only linked list, no one can tamper with it. So let's say at one point of time it tried to read something from here. When it read from this memory location, it got 2, but the next time it will read, it will not get 2, it will get 3. So this is also not a very good behavior, because if there is a program which is assuming this thing as a read-only data structure, and 2 times while reading from the same memory location it is getting different values, it might actually get confused. So these are 2 very strong reasons because of which you should never ever play around with the data of the linked list. So how to swap the links, how to reverse the links, not swap, how to reverse the links. Let's say you have 1, 2, 3, 4, 5 and 6. Let's say you have reverted this much of part somehow. So you start the process of reversal from here, and if you have reverted till here, it will be looking like this: 3, 2, 1. And because now this 3 instead of pointing to 4 is pointing to 2, so this 3 will be connected from the remainder, which is 4, 5, 6. It will be left alone, right? So it will look something like this. Now what you would want to do is you would want to reverse this part and connect it to this. Okay, so for that, what to do? What are the 2 most important nodes that you need to remember? Can you tell me the numbers? Which are the 2 most important nodes that you need to remember in order to be able to connect them? Head of each part. Yes, so you need to remember this 3 and you need to remember this 4, because if you do not remember this 3, what will you connect this 4 to? Similarly, if you do not remember this 4, who will you connect this 3 to? Right? So you need to remember both of them. So let me call it previous and let me call it current. Okay, so these 2 pointers are definitely needed, previous and current. Now while reverting, what will I exactly do? So what will I exactly do? I will want to change this link to point to here. Yes or no? I will want to change this link to point to here. But when I do that, I will lose this thing. Yes or no? I will literally lose this thing. So what do I do to remember that thing? So I can store this thing in a temp variable, and then I can easily revert this thing like this. And now once I have done this, then this is my one portion which is reverted, and this is my another portion which is not reverted. And now I need to change my previous and current accordingly. So what should be my new current? So my new current should be my temp, and my new previous should be the old current. So I just have to repeatedly keep on doing this as long as my current doesn't become null. The moment my current becomes null, it simply means that I have reverted the entire linked list. So let us see how can I go about it. So my initial linked list is this: 1, 2, 3, 4, 5, 6. Okay, so currently this is the non-reverted part, and my reverted part is nothing. It's literally nothing. Okay, so I'll start with a current equals to head. And what should be my previous? Can somebody tell me what should be the value of my previous? Because every time you are at a current, you make this current point to a previous. What will you want to make this 1 to point to? You will want this 1 to point to null, yes or no? And because of that, you will have previous equals to null. So your previous will be initialized as null. And now your current is moving. Your current started from here, went here, went here, went here, and went till the null. So your condition will be while current not equals to null. Yeah. Let's talk about this situation. What is the first thing that you do? First thing that you do is delinking this. Am I right? Do you delink this? Is that the first thing which you do? Because if you directly delink this, no. If you directly delink this, you will forget this. So before delinking, I told it at the beginning, before delinking, you need to store this thing in a temp. Am I clear? Yes or no? You need to store this thing in a temp, right? So I need to do temp equals to current next. Can I get a null pointer exception here? No, because there is already a safety check outside, right? Cool. Anyways, so I stored this thing in a temp. Now I can easily delink this. Delinking this means just making this thing point to this. So how do I do that? I'll do current next equals to previous. What should be the next line of code? So now you would want that your previous comes here, okay, and your current comes here. So after this, the next two steps will be previous equals to current and current equals to temp. So by the time this loop will be over, everything has been reverted. And what will you return? In this entire process, has the head been modified or not? Has the head been modified or not? It has been, right? The new head is 6. So what should I return? Should I return current? Will current be my new head? No. Current will not be my new head because take a look at the code. The loop only terminates when current becomes null. So my new head will be previous. So what I should do is, I should return previous. So if it is a returning function which is supposed to return the head, return previous. And if it is a void function, then you make your head equals to previous, whatever you want to do. But this last step is extremely important. What is the time complexity of this entire thing? It's just order n, right? And what is the space complexity? Constant space, right? So this is a really elegant iterative way of getting this thing done. So next what I want you guys to do is, I want you guys to reverse the linked list but using recursion. Very important interview problem where the interviewer forces you to use recursion to reverse the linked list. How many of you can do that? I mean, it's okay if you would not be able to do it correctly, but would someone like to take a try and talk about the steps involved in recursion? Do you guys remember how I reverted a stack and how I reverted a queue? Yeah, so basically I allowed recursion to do everything for me. So I did one small thing which was like popping something, and then I called the function again on the remaining part, and when that remaining part got magically over, then everything that was my remainder had already got reverted. So can I think of something like that, guys? Yes or no? And guys, sometimes I have seen people doing a very big mistake. They just learn one form of reversal, which is iterative form, and then they do not learn another form. Let me tell you, you will see some questions where both of them are applicable. I mean, if you just use iterative over there, your code will be messy, you will not be able to code. Similarly, if you just use recursive over there, might not work again. So you have to use a combination of both in certain questions, and I'll show you one such question. But before that, think how recursion can be handy. So let us all learn that. I'm going to explain it to you from scratch, and let us all see how that works. Let's say I'm willing to reverse a linked list which is looking like 1, 2, 3, 4, and this 4 is pointing to null. So let me ask you one simple question. What I can do is, if the first thing that I can do over here is delink. So delinking this one from the remainder of linked list is as good as making this one point to null. Or think of it in this way. I can write it like this also, but just for your convenience, I'm writing it like this. Making one point to null. This is the meaning of delinking. So disconnect this with this. The moment you disconnect this with this, disconnecting means just doing this arrow next equals to null. So it is automatically disconnected. Now can I say that, hey, I will not be able to see this much. I will be able to see just this much. So let's say you make a recursive call for the remainder part, which is 2, 3, 4 and null. Now let's say this recursive call somehow magically reverts it. Forget how it does, somehow magically reverts it. Then once this is over, it will start looking something like this. I asked you to bluntly assume it, right? First thing that you did was delink, and then I said that once you delink, you just are seeing this much. And then you make a recursive call for this much, and let's say somehow it magically reverses it, then this thing will look like this thing. Then there is one last thing that you need to do, which will give you the overall answer, which is reversal of this entire part. Can you tell me what should that last thing be? Anyone, guys, please quick. What should that last thing be that I should do? Yes, the last and final thing should be to link this thing. Sorry, this was by mistake. You should have told that. The last thing should be to link this thing back to this. So if I link this thing back to this, now this will look like 4, 3, 2, 1, null, and this is the reverted form of this. So this is how I want to go ahead. Now let us learn. So first I want this to get reverted, and then I want to do the linking process. So my code does this, and now this is invoked. This is on waiting call. Okay, so now I come over here. So just like this node, what will be the first thing that you will do? First thing that you will do is to delink. When you delink this 2 from the remainder, it will be like 2 null. And now you will call recursion on the remaining portion, which is 3, 4, and null. And now once this is reverted, then the final thing to do is to link this thing with this thing, because when this is reverted, it will look like 4, 3, and null. And when you link this thing with this thing, it will look like 4, 3, 2, null. So do you see one thing, that every recursive call, by the time it has executed all the 3 instructions, it has done the job that it was supposed to do. So this thing is on wait currently because this reversal is not yet over. So again, what will be the first thing that will happen over here is delink thing. So if I delink, this 3 will first point to null, and then I'll call reversal for just one node, and then I'll link it. Okay, what should I do here? A linked list that contains only one node, forget everything that lies above, just see this much. A linked list that contains one node is already reverted form of itself. Can I say that? Yes or no? Right? So this is already reverted. So the moment I see that node next is null, I can simply return at this point of time. So what would happen is, you would return here, and once you return here, then first this operation will happen, which will now link this thing to this. So it will be like 4, 3, null, and now this operation will happen. So basically, now do you see that when this is over, it has done its work because it has reverted this thing to this. And now in order for this to complete, this link will now kick in, which will link this 4, 3 to this 2. So this 4, 3 will now be linked to this 2. And now when this thing happens, it will link this 4, 3, 2 to this 1, which is 4, 3, 2, 1, null. So see, things will be very easy for you, trust me. What you have to do is, when let's say this is my function, okay, and this is your node P, okay, so P was connected to P next. So you stored, before disconnecting this, you had a temp wherein you stored P next, and only after storing this thing, then you will call P next equals to null. Now you will call the function recursively. Let's say it takes a node. You will call the function recursively on something which is 2. Can you tell me what should come over here? Given these 2 lines of code, what should come over here? Which variable is containing the value of 2 right now? Yes, it is temp that is containing it. Yes or no? So you can call func of temp. And now when this func of temp is over, what would happen is that this part, just look at this part, 2, 3, 4 would have got reverted and would be looking like 4, 3, 2. Now the final thing that I need to do is, I need to link this temp This is P. I need to link this temp to my original node, which is P. So the first thing that you did was to delink this P from P next. And the last thing that you should do is to link back that P next to P. And that P next is present in temp, so this is the last line. Now, there is one important thing over here to understand. This entire process is going to change the head. This entire process is going to change the head, yes or no? What will be the new head? Can you just tell me the value of new head? It will be 4, right? 4 will be my new head. So what I want to do is, when this function is over, it should return to its caller, which is main. It should return to its caller the new head, which is 4. So 4 should be returned. So it is the responsibility of every method call to return the head. What will be the responsibility of this to return to its parent? It should return the head of this linked list. What is the head of this linked list? When this is reverted, what will be the head of the linked list? Can you tell me that? So it should return to its parent the value 4. Similarly, when this is reverted, what will be the head? So again, when this is reverted, the head of this will be 4, which you return here. What will be the head of this? That would also be 4, so it needs to return 4. So did you see that every reverse function should return to its parent this value 4 only, which is nothing but the last node. And this is the most important point to understand over here. So I am assured that the return in a recursion happens from bottom to top. So what will I do? When I reach the bottommost, I'll return this node, and then when I receive this value from here, I'll return the same value above, and I'll also return the same value above, and I'll also return the same value above. So of course I am doing this thing, I am doing one more thing, but what I am returning is the same which the bottommost node had returned. So this will help you with the coding part of it. So now I am going to quickly write the code. Everyone look at the code. So let's say I have struct. What will be the return type? The return type will be node star. Node star or struct linked list star, whatsoever you name it. Reverse. And what will be the argument? So any linked list which is being passed has a unique identifier head, which can be a pointer P. Okay. So tell me, what should be my first line of code? It should be my termination condition, right? Yes or no? It must be my termination condition. And how do I identify my termination condition? If I see that P next is null, what to do? If P next is null, that means if the linked list which I have to reverse contains only one node, what should I do? I should simply return P, right? Yeah. So here I should simply return P. Otherwise, if I am here or here or here, what is the first thing that I am supposed to do? What is the first thing that I am supposed to do? First I should delink. Okay. Now delink has got two parts. First store it in a temp and then make this pointer null. So I will have temp equals to P next, and then I will do P next equals to null. This is the delink part. This is the delink part. What will be your next thing? Next thing should be the function call from temp. Okay. So now you will make a function call reverse temp. Okay. Now every function call is going to return you the actual head. Like you called this is going to return you this 4. So you need to actually grab this somewhere. So I'm going to grab this in a variable called head. So now this reverse is over and this 4 has come from here. And now there is one last link part also that I need to do. So can you tell me? So this is like recurse and receive head. And then there has to be one last part. Can somebody please write that last part for me? You know what you had delinked that is stored in temp. So you need to link that temp to something. So what should you do? You should do temp next equals to P. So the final thing that I'm supposed to do is temp next equals to this pointer P. And then what should you return? What do you return? Look at this code and tell me what should I return. Yes, I should always return the head. So just this much is the recursive code for this logic. Okay, look at this code and tell me what is the time complexity. Order n. This is order n. Why this is order n? Who can tell me the size of this recursion stack? The hint is that the size of the linked list is shrinking by 1 unit each time. So what will be the size of this recursion stack? The size of the recursion stack will be order n. So it is guaranteed that my extra space will be O of n. And at every level, there are just 2 jobs that I am doing. And so the jobs are order 1 jobs only. This is also order 1 and this is also order 1. So at every level I am doing constant work and there are n such levels, so the time complexity will be order of n. And the space complexity is order n because of recursion stack. Okay, can something go wrong with this code? This code has a very small mistake which I want you guys to point out. It is not functional mistake, it is with respect to null safety. Null safety can be violated somewhere. Yes, very good. What if the head of the linked list is null? I mean, what if the input linked list itself is null? Because if the original input linked list itself is empty linked list where its head is nothing but null, then the moment you call this for this null, you will perform this check and you will get a runtime error, which is your null pointer exception. So can you handle it? I think I can handle it very easily by having a condition over here that if my p is null or p next is null, I'll return p. So this way I can handle it easily. So this is one thing that you have to be very careful of, no matter whether you are writing recursive code or which kind of code. And now because of this condition, you know, you are safe everywhere because you came here because your p was not null. So this will never be null, this will never be null, none of them will be null. Okay, so this is how you can go on and on and on.